come in. Let me, a final notice. Okay, so after two successive reflections, this is reflection 1 and reflection 2. Ray 2 is now parallel to mirror 1. But initially, this is ray 2, okay? Ray 1. And we are to determine the angle between the two mirrors, okay? Now, solving this, we just must use the laws of reflection. This is the point of incidence. So at the point of incidence, we can draw a normal. So this is angle of incidence. This is also angle of reflection, but angle of incidence is always equal to angle of reflection. So if the angle of incidence is I1, angle of reflection is also I1. Then let's also, since this point is also a point of incidence with respect to this ray or mirror 2, we can also draw a normal. Okay, and this part is equal to angle of incidence with respect to mirror 2. So let's call it I2. Since angle of incidence equal angle of reflection, this is also I2. We are just applying the laws of reflection. Okay, now this part of the angle, because the angle between the normal and the mirror is 90, this angle here will be equal to 90 minus I1. This angle would also be equal to 90 minus I2. We are just applying the laws. So let's label this triangle O, A, B, C. When you consider triangle O, A, C, sum of angles in there, we have theta plus 90 minus I1 plus 90 minus I2, summing up to be 180 degree. So theta plus 180 minus out, bracket open, I1 plus I2. This is equal to 180. 180 would reduce to 0, and theta is equal to I1 plus I2 when that crosses the equal to sign. This is equation 1. Okay. Now, when we use triangle 2, this angle is also equal to theta because ray 1 is parallel to mirror 2. And when two lines are parallel, they have the same slope. So the angle between mirror 1 and mirror 2, this angle must be equal to, this angle here must also be equal to that angle, theta. And by alternating angle rule, theta must be equal to whatever is here. Class, are you following? Give me feedback. Are you following?
Yes, sir.
Okay, so when we consider the other triangle A, B, C, sum of angles in there, theta plus, this is 2I1 plus 2I2, this must be equal to 180 degrees. So that we have theta plus 2 out, I1 plus I2 is equal to 180 degrees. This is equation 2. Now from equation 1, we came to the conclusion that theta is equal to I1 plus I2. So substitute that into equation 2. Therefore, wherever we see I1 plus I2, we'll substitute theta. So we have I1 plus I2 over here. So we are going to substitute theta there. This is 180 degrees. We have 3 times theta giving us 180. Therefore, theta is 180 degrees divided by 3. Just is equal to 60 degrees. This is the result to the work set I gave. Yes, some of you got it spot on. Some of you got it spot on. Another way to also answer the same question. Stephanie, please mute yourself. Another way to answer the same question. Stephanie entry. Is using the rule of parallel lines. So ray 1 incidenting on this, and after 2 successive reflections, ray 2 is parallel to mirror 1. So incident, reflected. Ray 1, ray 2. Now, this is theta. When two lines mirror 2, mirror 1, mirror 2 is parallel to ray 1. When two lines are said to be parallel, they have the same slope. So if M2 is parallel to ray 1, so this angle theta between the two mirrors must be equal to what is here. Okay, since there's the point of incidence, when we draw a normal, angle of incidence will be equal to angle of reflection. And so this angle here must also be equal to theta, since this angle will be equal to this angle. If we draw a normal to this, angle of incidence will be equal to this. And because ray 2 this time is parallel to mirror 1, this angle here must be equal to this angle, theta. Parallel lines have the same slope. And so if this is I2 equal to the angle of reflection I2, then this angle here must also be equal to what is here. So when you consider the triangle ABC, you have sum of angles in there being equal to 3 theta. So 3 theta is equal to 180 degrees, and theta straight away is 180 over 3, which is also 60 degrees. So this is another way to analyze the same thing using parallel lines. So ladies and gentlemen, just as the work sets given. If you have any question, you quickly ask. If you have any question, quickly ask. I want to take attendance and drop it, okay, on the page. And we do that in order to whip up attendance. When parents realize their words are not joining, they will add their voice. So let me quickly do that and then get back to where we ended last time. Formation of images in Zoom user. What's your name? Zoom user. Zoom user, if you can hear me, what's your name? Or you don't use Zoom anymore? All right. Okay, so let's quickly go through formation of images in concave mirror. When we finish, we look at how images are formed in convex. So we discuss rules of the game. A quick discussion of the rules. Mirrors must be drawn to have small aperture. We don't draw a mirror to look like a whole tray. Just a small aperture will do. With the principal axis indicates the principal focus. So you take measure. The distance from P to F is the focal length. Then you must also measure the same thing, because the radius of curvature R is equal to 2 times the focal length. So if from here to here is 5, then from this point to this point must also give us the same value. Please, I don't have a ruler. You must measure. So this is the center of curvature C. So the first rule of the game says that a ray of light, all the rays must come from the object, which is parallel to the principal axis. After reflection, must pass through the focal point. So this is rule 1. So the first rule. The second rule 2 is a reverse form of the first rule. Light follows the principle of reversibility. So we must always quote the back to show that this is a concave mirror. So measure from the pole to the principal focus and the same distance. Evelyn, are you there? The second rule says that a ray of light coming from F or passing through F after reflection must be parallel to the principal axis. The reflected ray must be parallel to the principal axis. Incident reflection. Class, are you following? Are we there?
Yes, please.
Okay, so 3. The third rule. The same measurement. Please, this measurement, very, very important. Take your measurements. The moment you get that wrong, it will affect the accuracy of your ray diagram. A ray of light which strikes at the pole of the mirror must reflect at the same symmetry, so same angle. So the moment the ray hits the pole of the mirror, it will reflect and then be symmetrical. Being symmetrical means that this angle here must be, it's not exactly symmetrical. I need to. So when you are doing this, please, you must look at this very well. If it's not symmetrical, it will also affect the accuracy of your ray diagram. Good. So that's why, so you can even take your protractor to measure. So this angle here must be equal to the angle here. So incident, reflected. And then the last rule. The rules are what we use in determining the image. So after we have gone through the rules, we will apply it in forming image and then describe the nature of the image form. So please know how to use the rules, various rules very well. So F, all measurements are from the pole. The same distance for C. So the last but not the least rule says that a ray of light which incidents the mirror at 90 or normally, no matter where it's coming from. So here we are assuming that the ray is coming from above here and strikes the mirror at an angle of 90. So when the ray hits the mirror at 90, it's coming from up here and it is incidenting on the mirror at an angle of 90. After reflection, the reflected ray will take the same path as the incident and they will all pass through the center of curvature, meaning that the ray can come from above here or below. If it's from below, the ray will strike the mirror at 90. And once it incidents the mirror at 90, it must reflect back along the same path. So incident, reflected, and must pass through C so long as it's incident on the mirror at an angle of 90 degrees. So these are the 4 rules that will be applied or used for this game. Please, is that okay? Is there any question? Class, is there any question? All right. Can I flip to the next page? Because we want to also look at how the rules work for convex. Can I flip to the next page? If you have any question, please do not hesitate to ask. I'm recording the video, so if it is convex, how does the rule work? Ohima, are you here?
Yes, sir.
Edmond. Oh, Edmond is not here. Don't forget, a convex mirror has a virtual F and a virtual C. So for convex mirror, there is a coated side. F is here. So this is, the pole is here, P. All measurements are from the pole. So F is here. Then the center of curvature, C is here. We can extend the principal axis. We can extend it to the other side. So a ray of light parallel to the principal axis. Don't forget, convex mirror converges. Convex mirror converges incident or parallel rays. Now, I said this is convex. It converges or diverges. Okay, so the reflected ray must be diverted, but the diverted ray always appears to be directed from a point behind the mirror, and that is F. So the reflected ray, which is diverted, always appears to be diverted from this point. Now, because this point is a virtual thing, it's not actually there. Okay, we usually represent the ray which appears to be diverted from F using broken line. Please, when you are doing this, use straight edge. I don't have it, that's why. So for convex, when rays a ray that is parallel to it is also diverted, but the diverted ray always appear to be diverted from the principal focus. Let's draw two rays. Here, let's use two rays. Okay, just to explain this better. So another ray, Technospark 5. Please mute yourself. So another ray which is parallel to the principal axis will be diverged or reflected, but the diverted ray appears to be diverted from F. Let me get that well. For ray diagram, please always use straight edge to do that, because it must be straight, it must be neat. So, incident reflected. The reflected ray is always appears to be diverted from this point. So this is how the first rule applies for convex mirror. 2, the second rule, a ray of light passing through F, from F or passing through F must be parallel to the principal axis. A virtual F and C. F is here, same distance as C. This is the pole. Now, for this rule, a ray of light which appears to be passing through F, it appears to be because, note that the principal focus of convex mirror is virtual. So the ray coming from that distance appears to be passing through F. So this ray coming from above here must appear to be passing through F. F is virtual, so my broken line. So the ray appears to be passing through F, and after it interacts with the mirror, the reflected ray must be parallel to the principal axis. So this is the reflected ray. Let me extend the principal axis a bit, okay? So here the ray appears to be passing through F, and after reflection, it must be parallel to the principal axis. Let's use two rays. So another ray which appears to be passing through this, and after reflection, the reflected ray must come in that parallel manner to the principal axis. So the ray is coming from here, and after reflection, the reflected ray is parallel to the principal axis. This is virtual, so let's clear it and use broken line. So the ray which is coming to the mirror appears to be passing through this, and after reflection, must be parallel to the principal axis, which is the reverse form of the first one. So the rule obeys, or the ray obeys the reversibility rule. So beautiful. Class, are we okay? Class, are we fine with the rules?
Yes.
3. The third rule. F is here. C is here. A ray of light which appears to be passing through, okay, the ray is hitting the pole, and for the pole, it must reflect at the same axis. So this angle must be equal to whatever I'm going to. So incident, reflected. And the last rule is the one passing through the mirror, hitting the mirror normally or at 90. F is here, P is here, C is here. Now here, the ray, when it hits the mirror at 90, must pass through or appear to pass through C. appears to because C is virtual. The point C for convex mirror is virtual. So when the ray hits the mirror at 90, it must appear to so incident and then reflected back along the same path. This point is virtual, so we must use broken lines. Please, I'm coming. Give me a minute, I'm coming. Just a minute. All right, so these are the rules of the game. Okay, so we are going to use these rules to draw an image or form an image for concave and convex. And when we finish, we will describe the nature of the image formed. Please, is there any question? And in doing this, you just need about 2 of the rules to form an image. So let's quickly, are you drawing? Are you sketching? So I give you some time to do that.
Yes, please.
All right, then hurry up. Let me update the attendance.
Recording in progress.
Can we continue or you are still on it? Class, can we continue?
Yes, please.
All right. So I beg you, whenever you are drawing ray diagrams, your pencil must be sharp you must do a very neat work, meaning you must have an eraser. Okay, use straight edge to draw lines because ray diagrams must actually be so clear. Okay, so let's look at how images can be formed on concave mirror. Concave or convergent mirror. Mirrors must be drawn to have very small aperture. So you don't draw a mirror to look like a whole pan, just small aperture. Then usually reflections can go beyond the aperture of the mirror. One, you shouldn't draw a mirror with a very large aperture. So you just draw a mirror with a small aperture and then rule a vertical line behind it so as to cater for reflections which go beyond the aperture of the mirror. So that's my vertical line. Then you draw the principal axis. Then you coat the back to show that this is a concave mirror. The next thing is to take your measurement. If you are given measurement, use it. If you are not given, take your own measurement. Maybe I want my focal length to be 5 centimeters. So I measure 5 centimeters from the pole to the principal focus. Don't forget, all measurements must be taken from the pole. So the 5 centimeters must be taken from P to F. So where the 5 centimeter ends, that is the position of the focal point. The same distance must be measured from F to C. This rule is super important. If you don't do that, it would affect the position of your image. So if this is 5, this must also be 5. Are you there? Jude, are you there?
Yes, sir.
Okay, so this is the center of curvature. Now, the object can be placed, one, at infinity. At infinity, object can be placed between infinity and C. So 2, between infinity and the center of curvature. When the object is behind C or beyond C, it means it is between infinity and C. So between infinity and C is the same as beyond C. The object can be placed at C. Object can be placed between C and F, between C and F. It can be placed at F. It can be placed between F and the pole, between F and the pole P. Okay, so we'll take it one after the other and use ray diagram to describe how the image will be formed. So I'll first place the object beyond C or between infinity and C. I wouldn't start with infinity because I'm just starting with you wouldn't understand it so well. So we will later treat when it is at infinity and place at F. So the object is beyond C or between infinity and the arrow represents the head of the object. The foot of the object is on the principal axis. So this is the object O. All right. So any two of the rules can be used. Any two of them. I want to use a ray of light parallel to the principal axis. After reflection, what must happen? When the ray is parallel to the principal axis, after reflection, what must happen, class? Yes, class. When the ray is parallel to the principal axis, after reflection, what must happen? Anybody to answer that? Oh, let's not waste time. Share, go ahead. Nana Hefron.
The reflected ray must pass through the focal point.
Exactly. So after reflection, the reflected ray must pass through the focal point. So this is one of the rules used. Any two of the rules would give us an image. So I want to also use a ray of light. The rays must always come from the object, passing through C. You see, this ray is going beyond the aperture. So it means that I must extend the vertical line. I earlier said we don't draw a mirror with a very large aperture. You just draw small and then rule a vertical line to cater for reflections which goes beyond the aperture. So once the ray passes through C, then it means that the ray is hitting the mirror at 90. Okay, I can use this, or I can still use, if I don't want to use this, I can still use the other rule, a ray of light which is passing through F after reflection. The reflected ray must go parallel to the principal axis. I can also use this, and it will give me the same nature of image as if I had used the other rule. So incident and then reflected. Okay, now where two reflected rays, there's a reflection of the first one. I want to use different color in order to make things clear. Good. The second rule, I want to change the color. So a ray of light passing through F after reflection, the reflected ray must be parallel to the principal axis. You see the two, there's the incident of, and then there's the reflection. The two reflected rays are intersecting here. The point where the reflected rays intersect is the point where the image will be formed. The point of intersection of the two reflected rays is the point where the image will be formed. And where they intersect will be the point where the head of the image is formed. The foot of the object and the image eye is always on the principal axis. So the foot of the object is here, foot of the image is here. When the image is formed, the point where the two reflected rays intersect is the point where the image, the head of the image is. Please, are we okay? Lamp and Co, are you okay? All right. Now let's just discuss the nature of the image form. What is the nature of or the characteristics of this image compared to the object? So nature or characteristics of the image formed. 1, because the image is formed in front of the mirror, I can say that the image is real. So image formed is real. It's real. The image being real is due to the fact that 1, it is formed in front of the mirror. 2, this image is formed as a result of the actual intersection of these two reflected rays. So when two reflected rays actually meet, it forms a real image. So image is real because of these two reasons. 2, the image formed is inverted or turned upside down. Look at the head and then the foot of the object, and then the head and the foot. Or whenever an image is real, it will be inverted. So all real images are inverted. So image is inverted or turned upside down. 3, image is formed. Before we talk about the location of the image, compare the objects and the image. Which one is bigger? Which one is smaller? Ohima, compare the size of the objects and the image. Which one is bigger? Which one is smaller? Ohima. Oh. Okay, Yaya. Yaya, let me hear from you, or Rabia too.
Sir, please, the image.
The image is what? Is it smaller or bigger?
It's smaller.
Good. So object.
Please,
So object size.
Sir.
Hello.
Sir, please. Image.
Yes, I got you. So technically, If the image is smaller than the object, technically we say that image is diminished. Image is diminished. Image is diminished. So if image is said to be diminished, then it means that the image is smaller in size and in height than the object. If the image is bigger than the object too, we will say the image is enlarged or magnified. So the final description is that image is formed between C and F. Image is formed between the center of curvature and the principal focus. So these are the characteristics of the image form when object is beyond C. Objects beyond C or between infinity and F. If you have any question, quickly ask. Before we look at when it is at C, what happens? Any question here from? Evelyn, are you there? Evelyn. Who are those here? Evelyn, you are here and you are so quiet. Eunice, Ifwa, Jude.
No, sir.
As Jude, you have been contributing. Evelyn is quiet. What's the problem? Okay, so let's look at another location. Okay, so another location of just small aperture indicates the pole and rule a vertical line behind it. Then the principal axis. The pole is here. Take your measurement. Measurement, very, very important. All measurements must be taken from the pole. So assuming this is 6 centimeters, I must measure the same thing from F to C. This must also be 6. This time around, I want to place the objects at C. So when object is at C, you don't draw an object to look like a coconut tree, no. Can you try using at least 2 of the rules to describe the nature of the image form? I'm giving you 5 minutes to just sketch and figure out the nature of the image that will be formed. After 5 minutes, I'll come in to discuss that with you. Class, are you okay? Yaya and Co. Yaya Ohima. Rabiatu. Kirk. I'm giving you 5 minutes to, figure out, I've demonstrated one to you. So try and then think around it, use the rules. Let's see what you can be able to get. After 5 minutes, I'll come and then discuss it with you, right? Okay, all the best. I'll come back after 5 minutes. Start when? Your 5 minutes time is due. So a ray of light parallel to the principal axis after reflection must reflect and pass through F. So this is incident, this is reflection. Then a ray of light through F after reflection must be parallel to the principal axis. And here the problem is that if you don't take your measurement well, it will affect the position of your ray, of your image. Ideally, when you place the object at F, when you place the object at F, the image must also be, when you place the object at C, the image must also be at C. But because I am not using a ruler, and so estimating or taking measurement is difficult, my image is not exactly, it's supposed to be here. It's supposed to be here. Also be located at F, but from the look of things here, the problem is due to my measurement. So please, if you don't adhere to R is equal to 2F, use ruler to take measurement. It will affect the position of your image. It will affect the position of the image. Ideally, this image must be here. The image must be here. Now let's discuss the characteristics or the nature of the image form. 1, image is real. Real because it is formed in front of the mirror. Real because it is formed as a result of the actual intersection of two reflected rays. So image at C one, image is real. All real images are inverted. So 2, inverted. 3, image has the same size as the object. And then 4, image is formed at C. It's also formed at the same point C. Okay, so when you place the object at the center of curvature, these are the characteristics of the images formed. So we've done beyond C, at C. I'll leave between, when the object is between C and F for you to do. We'll jump straight to when object is placed between the principal focus and pole. What happens? Then we look at that of convex. Can I flip to the next page? Can I move to the next page? Hello?
Hi.
I said, can I move to the next page?
Sir, please, we are right.
So if you are writing, tell me. Oh, say, please hold on. It's worrying when you teach students and they remain so silent. Okay?
Okay.
It doesn't motivate the teacher at all. So please heal yourselves.
Sir, please, I'm done, but I don't know for others.
The others, because they are not talking, it means they have no issue. So let's move on. So let's place the object between F and P. This time, between F and P, I would extend the principal axis to go beyond the back. And you understand that for later, why I'm doing that extension. So take your measurement, please measure. I'm just estimating because I don't have what it takes to measure. So this is my principal focus, meaning the pole is here. And so I must estimate the same thing for C, but you must take measurements. This time around, I'm placing the objects between the pole and the principal focus. So the object is here. And we are using the same rules as we went through. A ray of light parallel to the principal axis after reflection must pass through F. So incident, this is the reflection. Then a ray of light hitting the mirror at 90 must reflect and pass through C. So the moment you see the ray passing through C, then it means it is hitting the mirror at 90. So incident ray, reflected ray back. Now let's look at the rays, the reflected rays as they go. Now, looking at the two reflected rays, this one, the one, you see the reflected ray is the one whose arrow is, okay, coming back along the same path. And then this is the reflected ray for the first law. Do they look like possibly meeting in front of the mirror? Do these two reflected rays look like possibly meeting in front of the mirror? Class, I'm asking a question. Look at the two rays, reflected rays 1 and 2. Do they look like possibly meeting in front of the mirror?
No, please.
So there's no way. They are getting more diverse as they continue to go. Now, it means that once they don't look like possibly meeting in front of the mirror, it means that there's no way real image will be formed in front of the mirror. So let's trace the reflected rays backward to see if they can possibly meet at the back. So we trace this backward. We trace the other ray backward because you've seen they cannot meet in front. As we do so, we realize that there is a possibility that the two reflected rays would appear to meet at the back of the mirror. Where they appear to meet will be the point where the image will be formed. So they will appear to meet here. Okay, so where they appear to meet will be the point where the image will be formed. And so we can this time describe the nature of the image form. Let's describe the nature of this image form. What will you say nature of image form? One, what are some of the characteristics that can be seen? Yes, we've done so for about 2 different images. So compare the image, compare the object, and tell me, Kirk. Kirk, go ahead.
The image is virtual.
Image is virtual. Image is virtual. And why is it virtual? It's virtual because it is formed behind the mirror. It is virtual because it is formed as a result of the apparent intersection of reflected rays. So image is virtual. Apart from that, what else can you say? Image is virtual. Nana here from.
So please, the image appears to be bigger than the object.
So image is magnified or enlarged. Image is magnified or enlarged. The girls, let me hear from you as well. 3. 3. We are discussing the nature of the image formed. So image is virtual, image is magnified or enlarged. And I hear from.
Sir, please, the image is formed at the back of the mirror.
So that is why it is virtual. Okay. Rabia 2, let me hear from you. Rabia 2, are you there?
Yes, sir.
Let me hear from you.
The image is erect or upright.
Exactly. So all virtual images are erect or upright, and all real images are inverted. So image is erect or upright. And just as Nana Heffron said, you can include image is formed behind the mirror location. Image is formed behind the mirror. So when you place the objects between the pole and F, this is the nature of the image form. And the only time where a concave mirror forms a virtual image is when the object is between F and P. Note this. So a concave mirror can only form a virtual image on only one condition, and that is when object is placed between F and P. All other positions, it will be real. So we are left with CF, we are left with object as infinity and F. Let's look at how, yes, Mackenzie. Mackenzie, I'm listening. Oh, it's a mistake. Let's draw 1 or 2 for convex. The rest will be given to you as an assignment. So convex has a virtual F and C. Let me read the message and then get back. Image distorted. No, here we don't look at the distortion. What distorted, what do you mean? Can you clarify what you mean by distorted, Mackenzie? So I can add my voice to what you mean by distorted. Because if you say distorted, then it means it is of low quality or blurry. So can you explain yourself? All right, so this is, let's For convex, let's first bring the object closer. So object is here. A ray of light parallel to the principal axis must be diverted, and the diverted ray must appear to be diverted from the principal focus. So rule 1. So this is the reflected ray. Then rule 2. Let's use a ray of light hitting the pole. The rays always must come from the object. So a ray from the object hitting the pole of the mirror must reflect at the same axis or symmetry. So this angle here must be the same as that angle where the reflected ray would come from. Now look at the two reflected rays, this one and this one. Do they look like converging in front of the mirror? Rabiatu, do they look like converging in front of the mirror? Eh? Do the two reflected rays look like converging in front of the mirror?
Yes, sir.
Rabiatu, listen to the question again. Maybe you were playing. Look at the two reflected rays, 1 and 2. Do they look like possibly converging in front of the mirror?
No.
No. Why? Why?
Sir, they cannot meet.
Because they are being widened or diverted the more as they travel. And so there's no way real image will be formed in front of the mirror. So to form an image, trace the reflected rays at the back of the mirror where they appear to meet will be the position where the image will be formed. So when you trace it, the two reflected rays appear to meet here. That will be the position for the image, the apparent or virtual position of the image. The point of intersection is where the head will be. The foot of the object and the image is always on the principal axis. Okay, so let's discuss the nature or the characteristics of this image form. 1, we are discussing the characteristics or the nature of the image form. 1, images. Anybody can start. Image is
Sir, please, the image is virtual.
Image is virtual. All virtual images are upright or erect. 3. Class, we are discussing the nature of this image. The more we delay, the more time we are wasting. I'm waiting for you. Nana Hefron.
Sir, please, the image appears to be smaller.
So, yes, when an image appears to be smaller, technically we say that image is diminished. Diminished. Four. Image is formed behind the mirror. Image is formed behind the mirror. Now, I'm giving you 2 minutes to quickly sketch. I'm going to use the same diagram for another location of the object. So hurry up if you are sketching.
Yes, sir.
Yes, if we ask your question.
Sir, please, can you say image is formed between P and F?
Here, no, because a convex mirror would always form a virtual image. Okay, so where the image, the point where the image is formed is actually not real, but because it is not in front of the mirror, it's behind. That's why we say the image is virtual. So for virtual images, we cannot say that it is formed either at F between C or an okay. All that we can say is that it is formed behind the mirror for virtual images. But for real images, it is real and we can measure. If are you okay?
Yes, sir. Thank you, sir.
Welcome. So I'll clear the ray diagrams and take the objects afar. So let's assume that the object is here. We are moving it far away from the mirror. Use ray diagram to describe or to check how the image will be formed. So the same rules A ray parallel to the principal axis after reflection. After reflection must appear to be reflected from the principal focus. So the reflected ray actually appears to be reflected from here. So incident reflected. But this is not actually what it is. It's a virtual thing. And this virtual thing, the reflected ray appears to be reflected or diverted from F. Use broken lines. Then a ray of light hitting the pole is reflected at the same axis. Let me repolish it. Hitting the pole must be reflected at the same axis. So you see, the reflected rays are not, look at the reflected rays. They are not in any way meeting in front of the mirror. And so no real image will be formed in front of the mirror. So let's extend the reflected rays backwardly, where they appear to meet will be the position for the image. So the reflected rays appear to meet at this point. Where they intersect, they appear to intersect is the head of the image. The fourth is always on the principal axis. So when we look at it, yes, image is virtual because it is behind the mirror or because it is formed due to the apparent intersection of rays. Image is upright or erect. Look at the fourth head orientation of the object, fourth head orientation of the image. So image is upright. Image is diminished. Look at the image size, object size, reduced in size. An image is formed behind the mirror. Now, for convex mirrors, no matter where you place the objects, the same characteristics or nature of image will be obtained. No matter if you choose to bring the object close, if you choose to bring the object far away and all that, you get the same characteristics of image. Image will always be virtual. Image will always be upright, diminished. Image is formed behind the mirror. Class, are you okay? Is that clear? Is that clear? So take note of this. No matter where you place the object, same characteristics will be obtained. Now, when we look at the first one, the first image, we saw that no matter the object position, the image is always between the pole and F. when we took it closer, the image formed was between the pole and F. We took it afar. Image is formed between the pole and F. You can take it very far again. Image will still be between the pole and F. It is of this reason that if you look at the side view mirror, driving mirror, okay, there is the writing that images formed or objects you see is always closer than they actually are. Meaning, the images formed by convex mirror is always closer to the mirror than the real object. So if you're a driver and you look through it, whatever the image you see in the mirror would appear closer to you. But in the real world, the object is far. So it is of this reason that we have that writing. Images seen in this mirror or objects seen in the mirror is closer than they actually are. I don't know if you've seen this in driving mirrors. Have you seen those writings on driving mirrors? Hello, are you people there?
Yes.
I'm asking if you've seen that writing on driving mirror. Images seen or objects seen in the mirror are always closer than they actually are. It is because a convex mirror would always form an image which is closer to the mirror than the position of the object itself. So these are the characteristics of images formed by convex mirror. Convex mirror would always form a virtual image, which is smaller in size, which is upright, okay, and virtual. Whereas for concave mirror, the image form depends on the location or position of the object. Okay, the image formed depends on the position of the object. The only situation where a convex mirror, a concave mirror would form a virtual image is when the object is between the pole and the principal focus. If you have any question, ask. If you don't have any question, then we'll end here and continue tomorrow. Tomorrow we'll be looking at when object is at infinity and it's at F, what happens? But for convex mirror, no matter where you place the object, whether at infinity or whatever, you get the same description or nature of image form. If you don't have any question, good night to all of you. We'll continue same time tomorrow. Bye-bye.